operates in harsh environments. So this is one example. Actually, this is applicable especially for automobiles. So in automobiles, most of the embedded parts we keep in harsh environments, or else in plants where we need to control the pressure, we need to control the heat of the furnace, we need to control the speed of the motors. In all these, and they're all usually part of a plant or an industry. That these are the examples of the harsh environment. That's the reasons most of the times our embedded systems will be functioning. Usually it is functioning in the harsh environment. That's the reason it should have a capacity to withstand in those harsh environment. It is not necessary that all embedded systems should be deployed in a controlled environment. Controlled environment is like a room environments. So usually computers we keep in a controlled environments where we can sometimes we can control temperature also. But for an embedded systems it won't work. The environment in which embedded system deployed may be dust, one or a high temperature zone, or an area subject to vibration and shock. Like dust is common in industries, high temperature is also common in industries as well as in automobiles, or subject to vibrations and shocks. These are all common in automobiles and as well as in some moving parts of the industry. Systems placed in such area should be capable to withstand all these adverse operating conditions. Adverse operating conditions. The design should take care of the operating condition of the area where the system is going to implement. That's the reasons when you are designing a system, we should make sure that in all these harsh environment, our system should work faithfully. For an example, if the system needs to be deployed, the other factors that need to be taken into consideration for embedded system to work in harsh environments is power supply fluctuation. Sometimes power may fluctuate, so small changes in the power should not change the functionality or should not change the accuracy of our embedded systems. For an example, if it is a integrated circuits manufacturing company where they may be using several motors or several actuators, those actuators should work in spite properly without any small errors, where accuracy is very important. Even power fluctuation should not cause any errors. Corrosive environments, these are common in ship-like system, or else if it is working in outer area, if the system is kept in open air. Component aging, so all this it should consider. Then distributed. The term distributed means that embedded system may be a part of a larger system. Usually most of the embedded systems are distributed because it consists several small embedded units. Many number of such distributed systems form a single large embedded control unit. Many number of such distributed embedded systems form a single large embedded control unit. One control unit, embedded unit, it consists small several embedded systems. An automatic vending machine is a typical example for this. This vending machine contains a card reader, a vending unit, card reader and a vending unit. Card reader if you consider as a one unit, and vending unit as you consider an. Each of them are independent embedded units, but they work together to perform overall vending functions. ATM machine is also another distributed system. Example for a distributed systems. A card reader embedded unit responsible for reading and validating the user's ATM card. Transaction unit for performing transactions. It consists of another unit called as a transaction unit. It is responsible for performing transaction. The currency counter for dispatching vending currency to the authorized person. a printer unit for printing the transaction details. So we can say that ATM machine consists one is a card reader unit, transaction unit, currency counter, and printer. We can visualize these as an independent embedded systems, but they work together to achieve a common goal. Another typical example of a distributed embedded system is supervisory control data acquisition systems used in controlled instrumentation applications, which contains physically distributed individual embedded control units connected to supervisory modules. Several sensors are connected to one control unit. That is also one of the maybe some processors, and several processors are connected to one main processor. These main processor we use for supervisory modules to implement a supervisory, and several small processors connected to several small sensors are used to implement small distributed individual embedded units. So one good required characteristic embedded system should have a small size and should have a less weight. Product aesthetics is an important factor in choosing products. These are common in mobile like or handheld devices like embedded systems. It may be a small mobile, or when you plan and buy a new mobile phones, you may make a comparative study on the pros and cons of the product available in the markets. Definitely the product aesthetics, size, weight, shape, style, etc. will be one of the deciding factor to choose a product. People believe in the phrase small is beautiful. This is generally whatever points we are talking here is a business points. Here people expect some mobile, it should have a small size and it should have a less weight, and it should be small in the sense for that particular functionality it should be small, shape and style, etc. Moreover, it is convenient to handle the compact devices than a bulky product. So bulky product, because most of the handheld devices we expect it should be compact. Not only handheld, most of the like Memedix printer is also its size is reduced, copier machine size is also reduced, and camera size is also reduced. So for an example, camera, we are expecting high functionality with small size and small weight, less weight. In embedded domain, also compactness is a significant deciding factor. Most of the applications demand small size and low weight products. Power concern. Power management is another important factor that needs to be considered in designing an embedded systems, because for an example, a mobile where power management is very important, because here battery size is also very important parameter. We need to reduce the battery size, so that's the reason a separate power management is required, so to efficiently use the power. Embedded system should be designed in such a way to minimize the heat dissipation. Heat is a biggest problem in all the embedded systems. Our system we should design in such a way that minimum heat should be dissipated. So if minimum heat is dissipated, the heat sink requirement is less, fan requirement is less, heat requirement is less, heat sink requirement is less, cooling arrangement required definitely will be less if the embedded system heat generated itself is less. That's the reason always we should design a system in such a way that embedded system should be designed in such a way as to minimize the heat dissipation by the system. Last kind of the production of high amount of heat demands cooling requirements. Production of high amount of heat demands cooling requirements like cooling fans, which in turn occupies an additional space, make the system bulky. So That's the reasons always we should reduce the heat dissipation so that cooling requirements we can reduce. In turns, it will reduce the total additional spaces of our embedded systems. Like in mobile phones, nowadays its size is reducing because the modern design heat dissipation is very less. Nowadays, ultra low power components are available in the market. Select the design according to the low power components like low dropout regulators, controllers, processors with power saving modes. So if most of the processors are controlled are having works nowadays in two modes or more than two modes, in which one of the mode is power saving modes. So it is very useful because whenever we are not using that embedded systems like mobile phones or any other systems, usually we keep that in power saving modes. So power management is a critical constraint in the battery operated applications because you may be knowing battery lifetime is very important. Not only battery lifetime or power backup. So with less power we want to run the system for longer duration. So that's the reasons power management is critical constraint. The more the power consumption, less is the battery life.